All right, let's get into our next section of notes here. So as a reminder, we're still in Unit 7, and we've been talking about quadrilaterals in general. So hopefully we just got done with 7.3, and hopefully we've taken the quiz by this point, and now we're adding in some more shapes that we know information about. Because we spent a couple lessons talking about parallelograms, and now we have a few others to mention here. Okay, so date today, or date that we would do this is the 16th, if you'd like to add that. And our objective, and this should kind of be changed, this doesn't only deal with rectangles, but also using the properties of rectangles, rhombi, and squares as well. Okay, so with all this here, little review, we talked about parallelograms a good amount, and we said if a quadrilateral is a parallelogram, then we have many different properties that we knew information about. So for example, one of the things that we knew is we knew the opposite sides were going to be congruent. And so that's what I'm going to put here. A little review, and I want you to write this down. Okay, the opposite sides of a parallelogram, not only are they parallel, but they're also congruent. Okay, the opposite sides are congruent. Another thing that we said, another property that we have, is we talked about the angles as well. And we said the same thing applies to the angles. The opposite angles are also congruent. Okay, and this is all information that we talked about when we did our 7.2 notes. Okay, so those two things that we talked about. There's another piece of information that we talked about with the angles as well. And instead of just talking about the opposite ones, we talked about the ones that are next to each other. And we said what we call the adjacent angles, or in other words, the ones next to each other. The adjacent angles, as a reminder, are supplementary, right? They're always going to add up to 180. So another piece of information that I know. So notice as we add on more of these kinds of properties, we just have more information that we could use if we were trying to solve for different variables or measurements. Okay, so we had these three first. We kind of practiced that a little bit, and then we had two that were kind of split off from the rest. Okay, the other two that we said is we said something about the diagonals. We said that the diagonals bisect each other. Okay, the diagonals bisect each other. And then lastly, one more thing that we had as well, other than the fact of both diagonals bisecting each other, we also said that one diagonal creates two congruent triangles. Okay, so lots of different pieces of information. If I say that something is a parallelogram, then automatically I have 5 things that I now know. Okay? The reason that we're reviewing this and going over this is because we're going to talk about shapes today. So for instance, starting with a rectangle, and all the shapes that we talk about today are types of parallelograms or specific types of parallelograms. So what that means is since these are all going to technically be parallelograms, all of this information that we just said with parallelograms is also going to apply to any other shape that we talk about today. Okay, so for example, a rectangle here, if I'm looking at the definition, okay, definition of a rectangle is a rectangle for us is a parallelogram with 4 right angles. Okay, simply put, a rectangle is just a parallelogram with 4 right angles. So we've seen, I'm hoping you've seen a rectangle before. You've talked about it in probably different classes when you were growing up. And this probably isn't the definition that you use, but this is our technical geometry definition that we use. It's a type of parallelogram, so all those properties still apply, and then the biggest difference is it has 4 right angles. Okay, so for example here, we know what a rectangle looks like. Okay, and all these still apply. The opposite sides are parallel, they are congruent, and then the only difference is that all the angles are the same, they're all 90 degrees. Okay, and that still satisfies the properties that we've talked about. The opposite ones are congruent, the adjacent ones are supplementary. Okay, this is important for us because now we have a property with a rectangle as well. So we can say that if a quadrilateral is a rectangle, then what information do I know? Well, if a quadrilateral is a rectangle, then what I can say is the diagonals are congruent. Okay, the two diagonals are going to be congruent, or in other words, the same length. So we've talked about information about pieces of them, how they bisect each other, and so on and so forth. But now we're saying the diagonals as a whole are going to be the same length. So again, an example here, if I draw this out, I need 4 right angles. Okay, I know the diagonals, not only do they bisect each other, not only do they create congruent triangles, but these two segments as a whole are going to be congruent to each other. Okay, so very helpful information, and now we just have so many different properties that we can use anytime I'm told or I say that something is a rectangle. Okay, so putting that to use here and putting that to practice. Example 1, I want you to take a second, I just want you to sketch this rectangle for me here. Okay, and notice the reason I know this is a rectangle is because I'm told this. If I was not told this, then none of these properties apply because it might look like a rectangle, but I don't know that for sure. Okay, so if I'm looking at this one here, it says if JL equals 5x plus 8, and if KM equals 9x minus 8, then what is the length of JL? Okay, so if we're going to set this equation up, like we just talked about with that property, since this is a rectangle, other than all the other piece of information that I also know that these two diagonals are going to be congruent. So all I need to do is set these equal to each other. I can say 5x plus 8 equals 9x minus 8. And then we can just solve from here. So I'll go ahead and subtract 5x from both sides. When I do that, these cancel, leaving me with 8. And then equals 9x minus 5x, which is 4x minus 8. Continue to solve. I can add 8 to both sides. When I do that, those will cancel. And I have 8 plus 8, which is 16. And then equals 4x. And then last step here, divide by 4. And I get x equals 16 divided by 4, which is 4. Okay, so notice this isn't my final answer. This isn't what the question was asking for, but this is going to help me. Because notice it's asking for the length of JL. So we've seen these kinds of problems before. What can I do now that I found x? Now I can plug that back in for the length that I was given for JL. So I was told JL is 5x plus 8. So this is going to be 5 times 4 and then plus 8. And then I just need to simplify here. So JL equals 5 times 4, which is 20. And then plus 8. So the length of JL here is going to be 28. Okay, and the good news is if I made a mistake and I plugged it into the other one, since they're the same length, it would come out to be the same number as well. So you'd still get the correct answer. Okay, so that's simple enough how we can use a property with rectangles here. All right, next one. Okay, another type of shape that we have here is a rhombus. Okay, another type of shape that we have is a rhombus here. And a rhombus is this. It is a parallelogram with 4 congruent sides. So a little similar to what we just talked about with a rectangle, we basically said this is a parallelogram where all the angles are congruent, except here they're all 90. Here we're saying a rhombus is the same kind of idea except with the sides. So in this case, all the sides are congruent. Okay, so for example, something you'll usually see as a rhombus will kind of look something like this. And let's try to redraw that. Let's do that a little better here. Okay, we'll draw here, and we'll try to draw this as close to what it would be here. So notice it's very similar to a parallelogram, except the only difference here is all the sides are the same length. Okay, and that might make you think of another type of shape that we are going to talk about later, but a rhombus just has this, just 4 congruent sides. Okay? And then this is important because we have a couple different properties with a rhombus if we see this here. Okay, so if a parallelogram is a rhombus, then I know 2 things. Okay, first thing here is I know the diagonals, and remember we still have those properties that we talked about with diagonals. They still bisect each other. They're not going to be congruent this time, but the diagonals are perpendicular to each other. Okay, the diagonals are always going to be perpendicular in a rhombus. So for example here, if I want to draw a rhombus real quick, all the sides are the same. If I look here and I draw these 2 diagonals, these are going to be perpendicular, or in other words, they're going to create 90-degree angles in the middle of this. Okay, so that's the first property that I know. Okay, second thing that I know here also deals with the diagonals, and what I can say is this. I can say each diagonal bisects a pair of opposite angles. Okay, each diagonal bisects a pair of opposite angles. Okay, this is helpful as well, so I'll go ahead and draw another one here. And let's just say, this is not going to be a scale. Let's say all the sides are congruent. This is a rhombus. If I just look at one diagonal here, like it says, what it's doing is it's bisecting the opposite angles. So for instance, when I bisect this angle on the top right, I would have 2 angles that come from it. And then same thing here, 3 and 4. I would have 2 other angles that come from it. What this property is saying is that all of these are going to be congruent to each other. So for instance, 1 is going to be congruent to 2, and then 3 is going to be congruent to 4, because that's what bisect means. It means to cut into 2 congruent halves. And then notice, since this is a parallelogram, that idea still applies that the opposite angles as a whole are going to be congruent to each other. So since the opposite angles as a whole are congruent, all the little pieces are going to be congruent to each other as well. So 1 would be congruent to 2, which is congruent to 3 and 4. Okay, so a couple more properties that we can use. Okay, so notice we can use anything with a parallelogram, because a rhombus is a type of parallelogram, and then we can use these 2 properties here with a rhombus. Okay, all of that information still applies. Okay, so putting that to use here, example 2, we see we have this shape here. I'll give you a sec to sketch this. Okay, so we have A, B, C, D, and again, we're told that this is a rhombus. If we're not told that, then none of these properties apply, and we couldn't set up our equations. Okay, so it's helpful that we're always given that. So we're looking at this here, and we're told AB is 10x minus 4, so I'll just go ahead and label that. And then we're told BC is 6x plus 8, and it wants us to just solve for x here. Okay, well notice, what should I do with these here? Very similar to what we've seen in the past. Anytime I see a problem like this, I know that these 2 sides here, since this is a rhombus, all the sides are going to be congruent to each other. So to set up my equation, simple enough, I can just say 10x minus 4 equals 6x plus 8. Okay, and now that I've got this set up, I can solve like normal. So I can go ahead and subtract 6x from both sides. When I do that, these cancel. I have 10x minus 6x, which is 4x, minus 4 equals 8. Okay, continue. I can add 4 to both sides to get rid of that. When I do that, these cancel. I'll bring that over here. I have 4x equals, and I have 8 plus 4, which is going to give me 12. And then last step here, we know to solve for x, we just divide by 4, and I get x equals 12 divided by 4, which is 3. Okay, so simple enough. We've seen these kinds of problems many times where basically the expressions that you're given are just being set equal to each other. In this case, I know I can set those equal to each other because this is a rhombus and all the sides are the same. Okay, other one here is a little bit different. It says, I'm told that the measure of angle BCD is 116. So if I look at this here, BCD, this whole thing is 116 degrees. And it's saying, if that is the case, what is the measure of angle BAC? So if I look and draw out BAC, it's just looking for this angle over here. Okay, so how do I figure out this angle right here? Okay, how would I go about doing that? Well, there's a few things that are going to help me. First off, remember, this is not only a rhombus, but this is just a type of parallelogram. And one of the properties that we said is that the opposite angles are going to be congruent. So for instance, if BCD is 116, then BAD, this whole angle, is going to be the same thing, since these are opposite of each other. So I know angle BAD, I'll just go ahead and write this down, is 116 as well. And that just goes along with one of the properties that we've talked about. Okay, so now if it's asking for just the half of that, or just this piece, 116, okay, and I kind of gave it away there, but remember, that was one of our properties that we just said. We said the diagonals are going to bisect each other. Okay, so not only are they going to bisect each other, but they're going to bisect the opposite angles. So for instance, if I have BAD and this is 116, to get BAC, I'm just going to cut that in half. So I can say measure of angle BAC equals what I get when I take the whole angle and I bisect it. Or in other words, I cut it in half. Okay? And when I do that, if I didn't know, I could just type this into my calculator here, but 116 divided by 2 is going to give me 58, okay, or 58 degrees, since this is an angle. Okay, so the tough part about these problems is not dealing with how to set up or doing the actual math, or dividing or setting up or solving for different variables. The tough part comes in making sure you know how to set up the equation. What are the properties that I know about the shape that I'm looking at here? Okay, and that's just going to come from making sure you're checking your notes and looking at all those properties carefully. Okay, so we've talked about rectangles. We've talked about rhombi, or a rhombus, which is just the rhombi is just the plural. Last shape that we have to talk about, simple enough, one you've probably heard of many times, is a square. Okay, and a square, in our terms, or the way that we're using it, a square is a parallelogram with 4 right angles and 4 congruent sides. Okay, and I'm not going to draw out an example for this because we know what a square looks like. But notice I'm just taking the two things that we've talked about today, a shape with 4 right angles and a shape with 4 congruent sides, and just kind of combining them together. So everything that I've talked about with rectangles, everything that I've talked about with rhombi, and everything I've talked about with parallelograms all come together to make a square here. So I don't need to write down any extra properties because the good news is that any property that we've said today, any of them that we've listed, all apply to a square because a square is just a mix of all of them. Okay, so with that in mind, we can look at example 3 here. Again, you can take a sec and sketch that, and we're going to use this information. So we double check beforehand, we're told this is a square. That's helpful because now every theorem, or every property I should say, is fair game. So for instance, first thing we're told QP is 3x minus 1, so this right here, 3x minus 1, and then we're also told this other line segment here, PS, is x plus 9. And it says if that is the case, what is the length of QP here? Well, if I'm looking at this, and I'm trying to figure out how I could solve for x and how I could possibly plug that back in, notice since this is still a parallelogram, all the properties that we've talked about with parallelograms still apply to a square. And one of the things that we said is the diagonals of a parallelogram are going to bisect each other. So this diagonal is being bisected and these two segments are still going to be congruent to each other. So I can say 3x minus 1 equals x plus 9. So notice as we start to add on more properties and look at different shapes, everything we've talked about so far with parallelograms is still fair game. Okay, and now we can just solve here. I can just subtract x from both sides. When I do that, these will cancel. I have 2x minus 1 equals 9. Okay, continue. I can add 1 to both sides here. When I do that, these cancel. I'll bring my answer over here. I have 2x on the left side, and on the right side, I just have 9 plus 1, which is 10. And then last step here, divide by 2, and I get x equals 10 divided by 2, or 5. Okay, so I get x equals 5, and then as a reminder, always good to double check. Do I need to plug this back in? In this case, I do. I need to plug it back in for QP. So I was told QP is 3x minus 1, so that's going to be the same thing as 3 times 5 minus 1. And now just simplify. So QP here equals 3 times 5, which is 15, minus 1, and we know 15 minus 1 is just 14. So length of QP, final answer there is going to be 14. So still using topics that we've seen before. All right, and then last thing here, it wants us to find the measure of a couple different angles. We don't have really anything else, and we don't really need any other information. So it says I want to find the measure of angle RQT first. Okay, well that one's pretty simple. Measure of angle QRT. This just goes back to the definition of a square. Remember we said all the angles are going to be right angles. So measure of angle QRT is going to be 90 degrees. Okay, so first answer is done there. Okay, all right, and then second one here also wants us to find the measure of angle QST. So if I go ahead and draw that out, QST here. So in this case it's close, except it really just wants only one of the little sections here. Well, I know the whole thing is going to be 90. At angle S, that's going to be 90 because this is a square. And then remember, like I said, any property or any theorem that we've talked about today is fair game. One of the properties that we just talked about with a rhombus is that the diagonals bisect the opposite angles. So for instance, if I have a 90-degree angle and I bisect it with that diagonal, I'm going to cut it into 2 congruent halves. And those 2 halves, if I just cut 90 divided by 2, are going to give me 45 each. So that would be my final answer, 45 degrees. Okay, so that's the good news with the square, is any property in general that we've talked about all apply to squares. Okay, so assignment for today should be posted on the class website if you need it. It should just be dealing with homework 7.4. As always, if you guys have any questions, feel free to let me know. But otherwise, thank you guys for watching. All right, thanks guys.